Welcome to this explainer. Today, we are going to completely demystify the absolute bleeding edge of human-machine communication. We're taking a really close look at a fascinating, wild initiative called Project Aeon. Over the next few minutes, we're going to explore exactly how this project is fusing raw neuroscience, brainwave decoding, and quantum technology to create something totally unprecedented, a 4D language. Seriously, if you've ever wondered how the complex, nonlinear thoughts bouncing around in your head could be translated directly into a machine-readable format without losing any of their richness, well, you are absolutely in the right place. Okay, let's dive right in by asking you to imagine a specific scenario. What would it actually look like if we could isolate the exact neural frequency of being in the zone? You know that feeling, right? That feeling of peak performance, whether it's an athlete sinking a game-winning shot or a programmer writing just a flawless, beautiful string of code. But what if that abstract concept of excellence isn't just a physical behavior or a fleeting, lucky moment? What if it's actually a highly specific, fundamentally decipherable pattern of electricity firing in your brain? Well, that exact question forms the core premise of Project Aeon. The project operates on this incredible hypothesis that human excellence across an incredibly wide variety of domains actually manifests as unique, measurable brainwave patterns. And if they're measurable, they can be translated. By utilizing advanced AI, Project Aeon isn't just trying to loosely read minds. It is specifically hunting for the neurological biomarkers that define peak performance. It's aiming to literally decode the very essence of human mastery. So here is our roadmap for today. We'll start with decoding the expert mind, move on to the 4D language transformation, look at measuring linguistic proficiency, explore quantum-powered language structures, and finally wrap up with the future of connection. All right, let's jump right into section 1, decoding the expert mind. So before you can build a language out of brainwaves, you have to actually find the signal in the noise. To capture these patterns, Project Aeon uses tools like EEG to record subjects while they're in known states of peak performance. But here's the huge challenge. The human brain is incredibly loud. At any given second, you're processing sensory input, remembering what you had for breakfast, and regulating your heartbeat all at once. To find the blueprint of excellence, the AI has to act as a highly sophisticated pattern finder. It separates all that noise of general, everyday thought from the highly specific signals that are tightly coupled to a core skill. They even combine this raw neural data with physical performance metrics to give the AI a complete, multimodal picture of what expertise actually looks like in real time. The really crucial point here is identifying these biomarkers. In this context, a biomarker is defined as a subtle, statistically significant deviation in brainwaves when you compare an expert executing a task against an average person doing the exact same thing. By isolating these specific markers, the system can pinpoint exactly what neurological excellence looks like in the pure data. That forms the foundational vocabulary for absolutely everything that comes next. Which brings us to section 2, the 4D language transformation. Now that we have that raw data, how do we translate it? Because standard English definitely isn't going to cut it here. Traditional language, like the words I'm speaking right now, or the text you read on a page, is a linear 2D system. It's string-based. You have to parse it sequentially, word by word, just to reconstruct the meaning. But Project Aeon's 4D language is a massive, massive conceptual leap. It's a living, multi-channel system, which they often refer to as a feature-bundled visual intermediate representation. So instead of reading left to right, this language is designed for parallel perceptual decoding. That means the system models dynamic conceptual fields that you interpret simultaneously. You're experiencing the data all at once, rather than in a slow, linear sequence. This is where it gets incredibly cool. Notice how active versus passive voice physically dictates the spatial layout of the glyph, whether it blooms outward or spirals inward. Tense and mood don't use extra auxiliary words, they literally dictate the core color, the hue, saturation, and lightness values. And honestly, my personal favorite, semantic ambiguity or uncertainty is represented by the Zolgo fracture metric. It's a visual distortion algorithm that visually signals exactly how uncertain the thought actually is. Grammar literally becomes a physical visual law. Moving on to section 3, measuring linguistic proficiency. Okay, but how do we actually measure the success of this translation? The project takes those precise biomarkers we found earlier and applies a very specific metric called semantic bits per spike. Traditional computing measures data in bytes and bandwidth, sure, but this metric is entirely different. It judges exactly how much true meaning, how much of that expert biomarker's semantic richness is successfully pulled from a raw burst of neural activity. It's basically a way to quantify how well the system understands the deep intent behind your brainwaves, not just the electrical volume. And this precise measurement is made possible by the brain MCP pipeline. First, high-bandwidth cortical spikes stream through a brain-computer interface. Next, the pipeline processes these biological signals, mathematically cleaning and organizing them. Finally, it converts those biological signals into JSON LD triples, which are essentially standardized machine-readable data fragments. It's effectively turning a fleeting thought into a permanent structured node within a cognitive knowledge graph. Let's dive into Section 4, Quantum-Powered Language Structures. Because mapping all this multidimensional data requires immense computational power, we have to enter the realm of quantum computing. The 4D language is so incredibly complex and context-heavy that it utilizes what the project calls quantum grammar. In this framework, the rules of the language act a lot less like the rigid traditional syntax we learn in grade school, and much more like the physical laws of a conceptual universe. It's inherently designed to reflect the nonlinear, probabilistic nature of quantum mechanics. This quantum engine drastically accelerates language development by utilizing phenomena like superposition. In this 4D language, a single glyph isn't limited to just one fixed dictionary definition. It can hold multiple probabilistic interpretations simultaneously. Furthermore, the system uses glyphic encryption interlocking, which is essentially a metaphor for quantum entanglement. This means that shifting the context of one concept instantly and non-locally alters the meaning of entangled ideas across the entire system. It creates this beautifully harmonized, perfectly synced cognitive web. And this builds into a totally fascinating user experience. As the project notes, this superposition only collapses into a specific, definite meaning when the glyph is explicitly observed, queried, or interacts with other glyphs. Just like a particle in quantum physics, this language is a dynamic, living organism. The meaning only locks into a definitive, readable state the exact moment you observe it or force it to interact with another concept. Finally, Section 5, the future of connection. So what does this convergence of neuroscience, 4D language, and quantum tech actually mean for our future? Well, the practical applications of this research are absolutely staggering. Think about AI systems that don't just mimic human output, but actually learn by emulating the decoded brainwave patterns of human experts, allowing for rapid, cross-domain skill transfer. Or imagine accelerated human learning, where you receive real-time neurofeedback to guide your brain directly into a state of peak performance. But most importantly, this technology promises to completely overcome traditional communication barriers. We're talking about revolutionizing accessibility for individuals with severe physical or speech disabilities, giving them a rich, high-bandwidth voice directly from their neural patterns. Now, obviously, with this kind of raw computational capability, Project Eon has to integrate operational safeguards directly into the system itself. They use human-in-the-loop processes, fully acknowledging that a mental state like excellence can be highly subjective. To keep the data translation accurate and totally transparent, every single operation is evaluated against the Ma'at alignment score. That's a dedicated metric designed specifically to ensure operational explainability and systematic accountability at every level of the cognitive architecture. We'll leave you today with this final provocative thought. As we master the decoding of brainwaves, and as 4D language and quantum processing converge to interpret those signals flawlessly, our very definition of communication is fundamentally shifting. Will the future of human connection continue to rely on the clumsy, slow-spoken word, or will we eventually seamlessly transmit our deepest intentions through the multidimensional quantum resonance of our own thoughts? It's a horizon that is a lot closer than we think. Thank you so much for joining us for this explainer, and keep exploring the data.